G'day, it's Mr. K. We are doing a quick review of the algebra unit that we did. So that was multiplying all sorts of variables, dividing fractions, indices, all those powers, all those good things. And we finished on expanding. Now, I've seen some really good stuff going down on the Education Perfect work. I know it says 3.5 hours of work, but to be fair, for you lads, it'll be probably an hour and a half. So that'll probably be us for the remainder of the term, and I'll be spending a bit of time on holidays just preparing our next unit and deciding on what that might be. I'm thinking linear algebra. I'm thinking solving linear equations. So today is just going to be a quick review of all that beautiful algebra stuff that we did. So the first thing we learned was multiplication. And in red pen at the bottom, I'll do our final record of learning. So this is going to be going out to both the top 2 Year 9 classes. So this is just going to be a quick review. So if I took x and I multiplied it by itself, well, you would say that is x times x, and you'd say that's a bit easier to say as x squared. Now, we don't write ones in algebra, all right? So I could surround x with ones, couldn't I? I could have 1 times x, I could also have it divided by 1, and I could have it to the power of 1, but that's all superfluous, right? I don't need any of that stuff. But what's happened here is that we've actually taken x to the power of 1 times x to the power of 1, and you can see that we're kind of like adding the powers. So a further example of this would be if I had x times x times x times x, well, that's x to the power of 4, isn't it? And to further this on, well, I would say that if I had x cubed times x, squared, well, you could pause this video and just have a think about what that might look like. But if I was to write out the long way, I'd write that as x times x times x times x times x. And what do we have here? We've got x times by itself 5 times. And that's a really long way of going about it. Is there a quicker and easier way for us to get from these powers to this power? And yes, there is. We can just add the powers, can't we? So if I had x to the 7 times x to the 5, well, that would be x to the power of 12. And there we have it. You can just add powers. It's really that easy. So a general rule for this would be that if I had x to any power and I multiply that by x to any other power, well, that would be x to the 2 powers added together. And so that is one of the rules that we went through at the end of this term. Great. So that's a quick introduction to multiplication, or should I say review. The other thing we have is division. And there's a lot of patterns in maths, so if you can see that we adding with multiplication, you might think, well, we must be subtracting for division, and you'll find that's true. So let's have a look. If I have x to the 7 divided by x cubed, well, let's write this out the long way. Let's write it out in fraction notation. So that's x times x times x times x times x, 1, 2, 3, 4, 5, times x on the top. Maybe I should have chosen a smaller number. On the bottom, that's the top divided by x times x times x. And you guys should be quite aware now from number that the order of multiplication and division doesn't really matter. Not in this algebra context right here anyway. So x divided by x, well that's 1. So that's just me timesing everything by 1, isn't it? And so that's also times by 1 when I cancel that x with that x. And then this x divided by that x, well, that's 1 as well. So it's a lot easier for me to just say that this is x to the power of 4. So we can subtract the powers. So another example of that would be x to the 5 over x squared. Well, I've got more x's on top than I do on the bottom, so I'm left with x cubed. Something that can be quite tricky though is when I have this around, say, the other way. If I have x cubed on top and I have x, I don't know, to the 6 on the bottom, well, now things get a bit complicated because now I'll have more x's along the bottom and less on top. So what I tend to do is I look at, well, if I cancel it down x's, I'm going to have more on the bottom. And how many more? Well, I'm going to have x cubed on the bottom. And then I'm wondering, well, what do I put on top? Because if I put 0 on top, well, that's just 0, isn't it? And I don't have 0. I have x cubed on the bottom. And what I put on top is a 1. Right, I put 1 on top. So it's 1 over x cubed. And so our general rule for this is any power of x divided by any other power of x is x to the a minus b. And so I need to go forward and I need to show you some little examples where you might have a bit of trouble. So let's do a real simple example. Let's go x to the 10 over x to the 8. Well, we can go x and subtract powers and call that x squared. Or you can think about how many are going to cancel top and bottom and we'd have 2x to the 2 left on top. But what happens when we use this rule and the b is bigger? Well, if I have x cubed and x to 7 on the bottom, well, if I was subtracting then that's x to the 3 minus 7, which is x to the negative 4. Now that is a correct answer. And what we say there is that is the answer written with negative indices. All right, that's an index, or the plural is indices. And so that's got a negative indice. Well, what if I was asked to write that with a positive indices? Because you boys know how hard it is to work with negatives. So we look at it like this. How many can we cancel top and bottom? And so I can cancel 3 on the top and I would have x to the 4 left on the bottom by the time I've done all the cancelling. And then I don't know what's on top, but there's always a 1. So that would go to 1 over x to the 4. And so you can see that those two things are actually the same. So this is our other rule, that if I have x to any negative power, well, that is the same as 1 over x to that power. And so a couple examples of that would be x to the negative 1 is just 1 over x to the positive power. We can use this now, mixed with our multiplication, to prove something quite interesting. 1 is just anything divided by itself. So x to the anything divided by itself. But we've just seen that in the division rule, that's just subtracting powers. So that's x to the a minus a. And anything subtracting itself is 0. And there we have it. A nice little proof that any number to the 0 is 1. So that is a nice little record of learning for you to add as well. So that is a quick review of the multiplication and division rules, and there is a power rule as well. I'm actually going to do a quick video after this of square rooting, and then I'll be moving into expand some fractional and divisional algebra. So I'll leave it there for now, and I'll get this uploading. See you soon.